Einstein once said that the universe must have an infinite age, but that was a mistake. The James Webb Telescope is causing a stir again, and scientists are starting to run out of ideas. The telescope is discovering strange structures and galaxies that seem to be older than the Big Bang. It almost appears as if researchers are looking into a world that doesn't fit with our old science, yet it's still the same universe. John Mather is one of the scientists who, despite the evidence, refuses to believe the universe is possibly infinite. Einstein, about 100 years ago, famously said, "Two things are infinite, the universe and human stupidity, but I'm not quite sure about the universe." At the time, researchers still believed in a static and finite universe where all objects had a fixed place. Einstein was a pioneer in the study of the cosmos, describing movements, sizes, and forces. He concluded that nothing is as fast or uniform as light. For a long time, even Einstein didn't know whether the universe had an end, but the more he researched, the more he believed the universe had some form of infinity. These views were later revised, leading to the Big Bang theory, which introduced the idea of expansion and an eventual end to the universe. But can this really be true? The James Webb Telescope now reveals a universe that challenges the Big Bang and shakes the foundations of Einstein's field equations. The telescope has made another major discovery: galaxy clusters older than the Big Bang. As if ancient galaxies weren't shocking enough, Webb has now discovered a cluster so massive it couldn't have existed in the early universe. Galaxies that appeared 200 or 300 million years after the Big Bang have already shocked science, and now, a cluster with hundreds or thousands of ancient galaxies has further upended what we know. The evidence is overwhelming, and scientists are being called to act, yet many cling to the Big Bang theory. Some suggest that matter grew faster than previously thought. But how was matter really created in the first place? Researchers imagine that the universe started incredibly hot, then cooled, allowing elementary particles to form molecules. Eventually, gas and dust clouds led to the formation of stars, with gravity driving everything. But according to calculations, the galaxies Webb shows us shouldn't exist yet. At that point, the universe should still be mostly dark and empty. John Mather, the project leader for the James Webb Telescope and a staunch advocate of the Big Bang, believes that matter was created more quickly. So far, efforts to reconcile these discoveries with this star boost theory, a theory of fast-growing galaxies, have failed. There are no signs of accelerated star production in the early universe. In fact, the universe and its galaxies appear remarkably similar to what we see today. Many alternative theories have emerged to explain these discoveries. Some physicists suggest ideas from quantum physics, like the multiverse, where our universe is just one of many. Roger Penrose, for instance, has found evidence that the universe is cyclical, repeatedly being born, existing, and then dying, only to start again. Other ideas propose that our universe is a bubble in a larger universe. If this is true, we might one day reach the edge of our bubble and discover a new space. The pocket universe theory suggests that different regions of space could act like pockets leading to other dimensions. The steady-state theory, once popular, is seeing renewed attention. According to this theory, the universe is constantly fed with matter from another dimension, maintaining a dynamic but essentially constant state. Though this theory was largely refuted, the discoveries made by Webb have given it new relevance. Black holes also play a role in these discussions. As vast amounts of matter are consumed by black holes, where does it go? Some theories suggest black holes break down matter into basic information, which is eternal, as proven by quantum physics. Roger Penrose's cyclical universe theory aligns with this idea, that our universe could be reborn from the information stored in black holes. There's another possibility. Our universe might be using black holes to expel old matter into another universe. This would mean our universe is in constant interaction with a parallel world, which we've yet to detect. If that's the case, we haven't discovered these matter streams yet. There's still much to learn about how particles acquire mass, as even the Higgs boson, once thought to provide mass, has shown unpredictable behavior. Our standard model of cosmology is full of speculations. Known as the lambda-CDM model, It combines Einstein's general relativity with observations of cosmic microwave background radiation. But the model assumes that the universe is homogeneous and isotropic on a large scale, which recent discoveries contradict. The model also assumes the universe consists of 68% dark energy, 27% dark matter, and 5% normal matter. But dark energy and dark matter remain elusive. We can only confidently describe the 5% of visible matter. Dark energy, believed to drive the universe's expansion, remains a mystery. Another aspect of the Standard Model is the Hubble sphere, which defines the observable universe. The Hubble radius stretches around 46.5 billion light-years from Earth, but that may only be a fraction of the true size of the universe. The further we look, the further into the past we see, and as our technology improves, we observe an ever-expanding universe with no end in sight. The inconsistencies between the old model and recent discoveries challenge the Standard Model so severely that it's no longer tenable. Scientists like John Mather are trying to integrate new findings into the old model, but so far, these efforts have failed. Albert Einstein, over a century ago, famously remarked that, "Two things are infinite, the universe and human stupidity, and I'm not sure about the universe." At the time, scientists believed in a static, finite universe, where objects occupied fixed positions. Einstein revolutionized our understanding of the cosmos, describing the vast interplay of forces and motions that define its dynamics. His groundbreaking theories on light speed and relativity led him to grapple with the idea of an infinite universe, though he eventually leaned toward a finite model. His views helped pave the way for the Big Bang theory, which became the prevailing explanation for the universe's expansion and ultimate fate. The James Webb Telescope, however, is shaking the very foundation of these ideas. Recent discoveries of galaxies and galaxy clusters that appear older than the Big Bang are challenging what we thought we knew. The most recent revelation, a cluster of galaxies so massive that it shouldn't have existed in the early universe, has rocked the scientific world. Galaxies appearing just 200 to 300 million years after the supposed Big Bang were already surprising, but discovering entire galaxy clusters from that era is mind-blowing. These findings cast doubt on the timeline of the universe's formation, suggesting that our current models may need drastic revision. Despite the overwhelming evidence, many scientists remain committed to the Big Bang theory. They argue that matter must have formed faster than we previously thought. But this raises fundamental questions about the origins of matter. The traditional view holds that the universe began extremely hot, slowly cooling down to allow particles to form atoms and molecules. Over time, gas clouds coalesced, leading to the birth of stars, with gravity serving as the guiding force behind these processes. However, the galaxies and clusters Webb has shown us shouldn't exist yet according to these models. By this point in time, the universe should still be dark and largely empty, with only a few early stars emerging. John Mather, the project leader for the James Webb Telescope, continues to champion the Big Bang theory. He believes the universe's early matter must have been created more rapidly than anticipated, despite ongoing struggles to reconcile these observations with existing theories like star boost, which describes galaxies growing rapidly by producing stars at an accelerated rate. Yet, there's little evidence of this happening in the early universe. Instead, the galaxies and cosmic structures Webb has uncovered resemble those in the modern universe, further complicating the story of cosmic evolution. As scientists grapple with these findings, alternative theories are gaining traction. Some physicists turn to quantum mechanics for answers, proposing that our universe may be just one of many in a vast multiverse. Roger Penrose, a prominent physicist, has presented evidence that the universe might be cyclical, continuously being born, living, and then dying before the cycle starts anew. Other theories suggest that our universe could be a bubble within a larger cosmic structure, or that different regions of space might behave like pockets, leading to other dimensions. These ideas, while radical, are increasingly being considered as Webb's discoveries continue to defy classical physics. One compelling alternative to the Big Bang is the steady-state theory, which posits that the universe is eternal and constantly replenished with matter from another dimension. Though this theory was largely abandoned in favor of the Big Bang, It's seeing renewed interest now that James Webb is challenging the idea of a singular beginning to the cosmos. Black holes also factor into these discussions, as some theorists suggest they could be channels for matter to enter or exit different universes. According to this view, our universe might be in constant interaction with parallel worlds, with black holes serving as the conduits through which matter flows between them. Finally, the discoveries made by the James Webb Telescope pose serious challenges to the standard model of cosmology, known as the lambda-CDM model. This model assumes that the universe is mostly composed of dark energy and dark matter, forces that drive cosmic expansion. Yet, dark energy and dark matter remain mysterious and undetectable, making up 95% of the universe according to the model, with only 5% being normal matter that we can observe. The growing inconsistencies between this model and the recent discoveries suggest that cosmology may be entering a new era of uncertainty, where old theories no longer suffice, and new ideas are urgently needed.